Hello and welcome back to another session of Effective JaRu, a series where we read effective Java and try to apply the items to Rust. So this time is item 10, always override toString. Okay, that's quite a strong one. Always override toString in the moment you basically have any class. We are back at item 10 here. On the left side there's a Java implementation and toString was added. It's quite interesting how the Java world seems to reason about toString. The default implementation, again, the one that you inherit from object, is the one that basically just prints type name at some address location, which is basically informing about the type and identity of the value there, which is pretty decent. It's also, the default implementation is a debug implementation, right? So that's debug to me. And the usage is just for debugging purposes, because actually the object identity is a valid way to identify any object, so that's pretty decent. Even though it's not very helpful in all cases, it's some way to deal with it, but it's debug. Otherwise, object would probably be, or the toString implementation would probably be implemented differently, maybe using reflectance or reflectivity to learn more about the actual subclass that is in there, or the actual type that is in there. So, well, it's argued then how you should document this and how it should be used. It seems that toString is sometimes used as a way to serialize things, and some types actually provide a fromString method that allows to parse the stuff that was returned from toString back into an actual instance, which is also interesting because this kind of is related to serialization. And there we go again with tying the serialization format to the particular implementation of the object, which is bad by default, right? This is the same as hashcode does, where the algorithm is basically internal to the object, so you can't change it later. Same with this toString thing. So long story short, in Rust you don't have that. First, you don't auto-inherit anything. I think the way I want to see toString from now on and in future in Java, and even it will be different though. I think toString is more like a display, but I see it more like a debug. But maybe I have to alter that thought because practice really teaches you a different thing. But in order to get debug in Rust, you just derive debug, which basically implements the FMT debug trait, which is something that you can get. As follows. So this will be the debug printed version of my P here, whereas this will be the display version, right? So that basically just kicks in the debug one. And there's a pretty printed debug version as well that we might possibly have a look at, maybe. Which would look like this, but I think it's this one here. So that prints the alternative debug version, which is even more pretty printed than the other one. So let's give it another P here to test that. So now we should see all the different printings here in one row, and the assert false thing is necessary to actually see what stdout was produced here. So that is display. Oh no, wait, that's the, oh no, now I see what this is doing, cool. So the new lines are added basically in the pretty printed version, debug version. And this is something that is auto-implemented for you by the compiler, so you just prints all the fields, right? And that's pretty neat. It has nothing to do with serialization, and you would never use this to serialize this item. For that you have Rust serialize or cert, which are different libraries basically that will do it for you. It always works by, similar to how the formatting works, you will be called with some sort of serialization instance, which you then call repeatedly in all your fields in order to inform about the data that is stored within your objects. Same goes for deserialization. That way you will, or you decouple the actual implementation from what's happening in your object. The great thing about this implementation here is that this toString will always allocate, right? I mean, allocation is something you probably don't think about in Java just because it's kind of omnipresent here. But in Rust, you don't even want to implement toString. You can do toString, of course, which will return a heap allocated string. But that's nothing you would ever do in real. I mean, you wouldn't do this as a primary way to get a string. No, primary way is this one, because that just makes the respective calls, and the storage is a implementation detail of the actual formatter that is provided here, right? So that is using virtual function calls here to pass on the data of yourself to the actual implementer. So that's not even a generic method here. So let's have a look at toString. I think it's coming in from std string. toString is the trait that you want to implement, and if you wanted to implement it here, I think we might even no, actually there is no auto. There might be an auto implementation for it because we have implemented display, and I think this might already implement toString for us, but I'm not sure. Yeah, so let's test this. So now we should be able to call toString and get the same result. Let's see if that is close to what it is. Probably not. Oh, actually that totally worked. So I can remove this part here. And yeah, so as I said, toString, let's have a look at this. I mean, just to be sure. Everybody, or I'm on the right track here, but the toString trait really just implements a toString method, and this is auto implemented here. toString for t, where t is display and unsized, right? And this is exactly what happens for us. I still wonder why this must be unsized. Because if it would be sized, then the compiles the size would be known in compile time. Let's have a look at this implementation then. For t here, that is that, and we implement display, even though I'm not quite sure why we are supporting unsized. Maybe everything that is sized supports unsized as well. I think that might be the case. Anyway, so what happens is we get a string buffer here, which supports the write interface, by the way. Then we can just, that's cool, and we can just write ourselves. That's very nice. Write ourselves into the string using the write fmt implementation here, and then use the format args macro to get kind of the information that we need to provide to write fmt to get this done. And shrink to fit, I think it might actually free memory that wasn't used, because when the buffer grows, then it will actually overlocate a bit, and the shrink to fit will free that memory again, I think, possibly. Something like that. All right. And yeah, let's have a look at write fmt. It's nice to be able to look into the code that easily. Write has write fmt. So that's awesome. Every writer basically supports formatting that way. This means you will never have to allocate just to get formatted output. And this is really a great thing about Rust. Memory management is all under your control, and you will write very, very efficient code that way. That's totally awesome. Yeah, so that's basically, this is all you need to do the same thing in Rust that you do in this implementation here. And it's super clear what these things are for. One is for display, one is for debugging, right? And you can control them both. It will be quite interesting for you to see that the debug implementation has the same interface. So fmt debug has exactly the same signature, right? But we can choose which trait implementation we want to use in the moment we are making the respective call. So that's a very nice solution. It's clear, it's easily done. It's, also makes clear that this is not supposed to be used for serialization, even though you could. We don't provide a from string conversion here, which we could, obviously. We could. Maybe we have to do it because it will be in one of the next examples. But that shall be left until later. Thanks for watching and have a great day.